Hello, I'm Felix Burkhardt, and I would like to show you nkululeko, a tool to do machine learning, speech-based machine learning on the fly without programming, without the need to program. This is a hands-on tutorial, so I'll free my desk for you. So here, see my desktop. This is the main page of nkululeko. First, I'd like to say a few words on that. So it's hosted on GitHub. It is free of charge, and it's actually open source. And the license is MIT license. So I think that lets you do almost anything you would like with it. Of course, I'm happy if you use it for science, that if you cite my paper, but anyway, you can also use it commercially if you want. So nkululeko, a project to detect speaker characteristics by machine learning experiments with a high-level interface. Actually, the interface is not very high level, but it doesn't involve programming. That's what I mean with high level. The idea is to have a framework based on other really great frameworks that can be used by people not being experienced programmers. For example, linguists that don't know how to program but still want to do speech-based experiments. So the main features, you can see them here in the in this file. There's an overview on all the options that you have. It's like the manual of nkululeko. That's everything you can do with it. But you'll see that later, I guess. There's a hello world example that should make get you to set you up it fastly and use nkululeko. And that's what I wanted actually to do here in this tutorial. Go through it on Windows, actually. So generally, I would advertise a Linux system to be used for any science projects, but I'm aware that most people use Windows, or many people do. And also, I think the people who do use Windows struggle more with programming and science stuff. So this is for you, especially on Windows. Going back to the main nkululeko page, there's a blog post I have a blog. Then show you here. So this is my blog called Speech Surfer, and it's full of posts on nkululeko. So here you can find help too. And that's about it. There's a paper and there's this video that I'm currently recording. So to give you a quick overview, you can do confusion matrices. This means you can do speech-based experiments and then see the results in form of a confusion matrix. For example, if you want a machine to classify emotional speech, then you can see how well that worked in the end by looking at the confusion matrix. It usually means that the rows represent the intended emotion and the columns represent the predicted emotions. So if you have a strong diagonal, then that's great, because that means that angry has been predicted as angry, happy as happy. Not so much here. You see, most of the happies have been predicted as angry. Yeah, because this is a prediction. So it's supposed to be happy, but it is angry, predicted as angry, and so forth. What else? If you do neural nets, they usually are trained in epochs, and you can see the phenomenon of overfitting, for example, when you look at the curves for the development set or the test set and the training set. So the training set always should get better, but the development set somehow gets worse after a while, and this is the point of overfitting. So it's useful to look at epoch progression plots. You might be interested in feature importance. So usually machine learning works like this, that you extract acoustic features and then you feed these features to a machine learner. And so you might ask yourself the question, but what features are the most important of all the hundreds that I fed you? And so nkululeko can do that for you and order it. So in this example, the the median value of the first formant was most important for this kind of problem. Again, acoustic feature distribution. So then you might be interested, okay, the median value of the first formant is important, but how does that relate to the emotions that I have? And you see here distribution plots for the happy and the neutral ones and the sad ones. And you see, and the angry, you see especially that for the angry samples, the distribution of first formant median values over samples differ strongly from the ones sampled for sad, yeah, samples here. Disney plots are very useful. They boil down all the dimension of your acoustic features to only 2 dimensions, so they can be plotted in a space here, like here. And if you then color the samples with the intended emotion, not the predicted one, but the intended, you can already get an idea how good your feature space performs, yeah, with respect to your problem. So in this case, keeping basic emotions apart. Then one more thing I'd like to show is data distribution samples. So you can just let nkululeko show you the distribution of the samples that you have. For example, in this case, what emotions are there, or how many samples per emotion are there in your database, and how many of them are spoken by female voices and how many are male voices. That's it. I'll have a little break here and record another video to show you how to set up nkululeko. And I would do that by stopping first Freigabe and then this video.